All right, so here we're looking at credit cards. So the annual interest rate on a credit card is 18.99%, and it's compounded monthly. So that would be a good rate sometimes. Right now, in the past, it used to be a really high rate. So it all depends on time. So how long will it take to pay off an unpaid balance of $1,735.55 if no new purchases are made and the minimum payment of $30 per month is made each month? All right, so that seems like it's going to take a long time because if you just divide that out, that'll be quite a while. So for the purposes of the problem, we're going to assume there are 12 equal billing cycles each year, and the $30 payments are credited at the end of each month. So what we do is we use the present value formula with the PV equals that, the payment of $30, I is our 18.99 per month, and solve for N, which is the number of payments. So here it's going to be one of those things. We can work it out using logs, or we can plug this into our calculator and do numeric solver and solve for n pretty directly. But if we do it the long way, this is how we do that. And we do this. We have to take log both sides, bring that n down, and then we end up with n is equal to this value. So kind of a long and nasty way, but we've worked them out like that before, so that's how it works. And again, just plugging all of that into your numeric solver would get it directly. Now, if we plug all that in, we get it to be 157.4 months roughly, and so that's going to how long it's going to take you to pay that credit card off. Now, how long is that? Well, if you plug that into your calculator, you can divide by 12 and you're going to get over 13 years in 1 month. So a long time to pay off that little bit of value if you're just making that small monthly payment. All right, so that's all I have for this section. Oh, except for the summary. I forgot about the summary. So let's do the summary here. So the summary strategy for solving these financial problems is first, determine whether the problem involves a single payment or a sequence of equal periodic payments. Simple and compound interest formulas involve a single present value and a single future value, whereas ordinary annuities may be concerned with a present value or a future value, but they always involve a sequence of equal periodic payments. Now, step two, if a single payment is involved, determine whether a simple or a compound interest is used. And often simple interest is used for durations of a year or less, and compound is for much longer periods. So that's kind of a key there. Now, step three, if a sequence of periodic payments is involved, we need to determine whether the payments are being made into an account that is increasing in value, which is a future value problem, or the payments are being made out of an account that is decreasing in value, which is a present value problem. So if you're paying in or pulling out, that's going to give us a difference there. And remember that the amortization problems always involve the present value of an ordinary annuity, okay, because you're doing the decreasing value. So this is kind of the overall strategy, I would say, to really help you out. So you have to start over here, and then is it a single payment or a sequence of payments? If it's a single payment, is it simple interest or compound interest? And depending on which one it is, you either go here and do the simple interest, or you go here and do compound. So this is compounding, and this is compounding continuously. Now, if we have sequence of payments, then we can do a future value of an ordinary. So future value equals payment, and then 1 plus I to the n minus 1 over I. Or is it a present value of ordinary annuity, where we're looking present value is the payment times 1 minus quantity 1 plus 1, 1 plus I to the negative n over I. Okay, so that's kind of a good table to remember these things by. And so if you actually do that, that might help you to put something on your note card or something for an exam. All right, so that's all I really have now.